Typically, when we start to get into a course like this, everyone thinks this is a software development course. This is really a design course, okay? So this is all the things that you're thinking about when you're starting to build your software so that you can start preparing and organizing things the appropriate way. Again, I'm Dr. Tony Barber. I have an undergrad in computer engineering. I did that a while back. Finished there and moved here and became a consultant in the area. So I started working at Booz Allen and Hamilton Consulting. While I was there, I went out to do my master's in system engineering management at GW. And then I continued into the field of systems engineering. So I am a system engineer through and through. But again, system engineers do a lot of different things. I code, I build robotics, I do a lot of design work, a lot of architecture work, so I'm just everywhere. I also realized that in order for me to be impactful across the work that I was doing, I needed to learn a little bit more about business. So I went and got an MBA. Did a postgrad in org development at Georgetown, and then quickly jumped into a doctorate. And I did my doctorate at GW as well in systems engineering. And then I have a couple of other areas that I went into after that. Number of certifications. On the right-hand side, this is where it gets interesting. What do I do today? I do a lot of things. I am a principal advisor to the CIO of the Army. So I spend a lot of time advising senior leadership in the Army on technology, explicitly around architecture. So we do a lot of architecture work in that areas. But that doesn't sort of take us away from other areas like cyber and data and cloud. So we do a lot of work across the way. Of course, I'm here as a lecturer, professor at the University of Maryland. I teach, I just taught a course yesterday, model-based systems engineering. So you'll usually see me in the Institute of Systems Research doing a lot of system engineering support work. I own a company called TD Watts Consulting. I've owned that for a number of years. I also advise at a couple other companies, one called Acquired Data Solutions and then another one called Nucor Vision, where I play multiple roles in advising leadership on how to do great things across various industries. And then also another company, Salvatore Systems. I do business development support work there, and I own a nonprofit. So ask me when I have time. Absolutely none. I do a lot of things. All right, so let's talk a little bit about the course itself. And the real objective here, especially across most of the areas around ENPM, is the why. So really understanding why you're doing what you're doing. You're actually leveraging the school to prepare yourself to be amazing inventors, amazing engineers, and do some great things. And so we're gonna spend most of our time sort of rewiring your mind a little bit so that you can start thinking through why you're doing the things you're doing and how is it going to help society. And then we're going to start digging into the step-by-step methodical pieces with building it out so that by the time you get to, opening up your, building your code and start to developing those things, you have everything down on paper and you know exactly what you're doing and there's no questions, right? There's a number of different courses that really drive out from here. There's 611, which is a prerequisite. I think sometimes it's waived, so some students here haven't taken that course yet. There's a couple of other ones. There's usually an alignment of the way we go. And I usually, are you familiar with life cycles, like software system life cycles, right? A lot of folks jump into implementation without taking anything around requirements and design. It's not a good way to go, right? I'm an engineer, I'm a systems engineer, so I follow life cycles religiously. I always ask the question, what do I start? What do I do first, right? So it looks like the courses aligned in the program are aligned in that direction to sort of help you build and get to that point. So by the time you get to this course, you should have already talked about sort of the foundation of what system engineering is. Software engineering is. You probably already did some coding. I saw a number of your transcripts, so that's what I was looking for when I approved a lot of you for joining the course. I looked at your transcripts, and I wanted to see whether you've taken a programming class, because I'm not interested in teaching you how to program. I'm interested in teaching you how to design and prepare for programming. Okay? Requirements, of course, which is part of that life cycle. The life cycle starts off with concept, then you got requirements, then you have this thing called design, which we're in now. You work your way to implementation, and you start working your way to sort of what we traditionally call tests, but it's also verification exercises onto, deployment into. So why? Why? Teach critical design skills that will help you in your professional lives as software engineers. That's the why. That's why we're here. I want to teach you some things that you can take with you. Not just the regular stuff that you learn in the textbook, but also some life learning, so that you can be successful in industry. The what, or the outcome, is to be able to effectively select and use principles and methods and techniques and notations and tools and practices, to develop, document, verify, and validate a good enough architecture and detailed design of complex and high-quality software products. Right, so we're going to go through a number of different techniques and methods that's going to help train your mind into thinking about those things. And I always, and I'll go back to this, you'll hear me talk about the analogy of having a tool belt, a belt that has tools on it. I'm giving you your tools on your tool belt. So imagine you have a tool belt, and I'm giving you all these processes and techniques that you're going to be able to leverage and use. The thing is, I can't tell you when to use them. You have to be intuitive enough to say, I need this hammer to hammer this nail, right? And so I'm going to give you, cases where you start to think through it and say, which tools that I use, so you don't, pick up a screwdriver and try to hammer a nail. You pick up the hammer, right? So we're going to talk through these so you can start thinking through it yourself. Again, the way engineers, the big areas of doing engineering is you have the power to decide how you want to do the things you want to do, right? How you want to use the processes and techniques to build great things. But you have to use discernment to determine which ones are the right tools to leverage so that you're using the right tools to do the things that you're doing.